Okay, in this video, we're going to see how to calculate some of the various quantities that we are interested in concerning residence time distributions. So this is a combination of Fogler examples 16.1 and 16.2. In these examples, we study a reactor that is where a pulse experiment is being run. So specifically, a sample of the tracer hydine is injected as a pulse into the reactor, and then the exit concentration is measured as a function of time. That's given in the table at the bottom. What we want to do is construct the CFT curve, the EFT curve, the FFT curve, determine the mean residence time, and also determine the fraction of fluid that spends between 3 and 6 minutes in the reactor. Okay, so one second while I find what I'm doing here. Okay, so I'm going to do this using a combination of Polymath Plus and Excel. So first I'm going to go over here into Polymath Plus, and as you see, I've already kind of started this. I'm going to start from the beginning though. So I'm going to start with an integration. I'm going to go to this integration model. And what I'm going to do now is load my data into this model. I'm going to say I have T data and C data. And actually, I'm just going to delete all of that. I'm going to say, and I'm just going to load in the data, the given information. And that's going to take me just a second. Okay, so now what I want to do is set up a function. So my x values are my t values. My y values are going to be my c values. In the demonstration model, it was what I guess they had, what they have. T plus 25, that's not what we're going to use. We're just going to say y is equal to c. The first thing I want to do is create a CFT curve. To do that, I just have to plot this data. But I'm going to do two things at once. I am going to integrate the data, which I'm going to need for my EFT curve, and I'm also, in doing that, I'm going to get a plot, just by the way that Polymath Plus works. So I push solve, I get my CFT curve, that's right here. I also get the integral of my CFT curve, which is useful because I need that. I need that to calculate my EFT curve. All right, so let's go back. Let's do a couple things. Let's go back over here to my OneNote file. And let's say we're going to do problem 1 here. C of t is plot the data in the table. And so I've done that. I can go back over here, and I'm going to just screenshot this. And then I'm going to come over here and grab it. And I can label the data. T is going to have time units. C of t is over here, and it has units of grams per meter cubed. All right, so that is going to be problem 1. Problem 2 says give the EFT curve. So the EFT curve is going to be equal to the CFT curve divided by the integral from 0 to infinity of the C of t curve. So basically I'm going to normalize that C of t curve. For us, we don't have data to infinity. We have data to 14 minutes, and we also know that at 14 minutes the concentration goes to 0, which, since it's been tapering down here, we can rest probably assured that what happened was that all of the tracer has come out. So if we waited till infinity, we wouldn't get any more. So if we want to then plot the E of t curve, we can basically take this integral here on the bottom. Our integral is going to be between t equals 0 minutes and t equals 14 minutes. And we already have that answer. So if we go back over here to Polymath Plus, we already know what the value of the integral is. What I'm going to do is I'm just going to copy and paste that value. And I'm just going to click solve again. That's going to give me my E of t curve. That's here. It also gives me the integral, which is equal to 1, which is exactly what I want it to be. Basically, if I sum up all of the probabilities of the different residence times, I should get a value of 1. So my E of t curve, bring that back over here into Polymath Plus, and what I will do now is label it. So the time is in minutes. This is E of t, and it's got units of minutes to the -1. Okay, so now I want my f of t curve. So 3. F of t. F of t is going to be integral from 0 to t of E of t dt. So basically, I'm not just going to integrate between 0 and 14. I have to integrate at each step along the way to get my f of t curve. So this is where I am going to use a combination of Polymath Plus and Excel. So first I'm going to go over here. I already have my E of t loaded up, and basically what I'm going to do is change my limits of integration to each data point. I then get a value here. I'm going to load that into Excel. So my first value is 0. As you see, I've already got here my concentration versus time data, and what I'm going to do is I'm basically just going to go back and forth, copying and pasting for each one of my data points. So this is going to be a little tedious. Thank you for your patience. I know this last data point is 1. Actually, it's 0.99999 repeating. I've already done that integral. Okay, so that's my data loaded up there. What I'm going to do now is create a chart. So there is my f of t curve. I'm going to copy and paste this, come back over here into OneNote, put that there, and I'm going to say, label my axes, I have f of t, and that's going to be unitless. And then I have t, that's going to be minutes, inverse minutes. And what I want to do is show my work there. So, well, maybe that's a little bit hard to do, but basically, so maybe I'll explain it. We'll say obtained by integrating e of t zero in t for each value of t in the table. Okay, next what we want to do is find the mean residence time. The mean residence time is equal integral 0 to infinity of t times e of t dt. I am going to obtain that by going back over into Polymath Plus. This is my e of t curve. I've already got that in there. I'm going to multiply that by t, and I'm going to integrate between 0 and 14. 14 is integrating to 14 minutes for this data is equivalent to integrating to infinity. I'm going to push solve, and I get this value, 5.11 minutes. So I'm going to say, I'm going to go back over here to OneNote and say is equal to 5.11 minutes. And I can show my work in this regard by going back over here. I'm just going to give a snapshot of what I've done. Bring this over here. And what I will say is obtained by integrating with Polymath Plus. Okay, last thing I want is the fraction of fluid that spends between 3 and 6 minutes in the reactor. To do that, I'm going to integrate the e of t curve between 3 and 6 minutes. So if I go back to Polymath Plus, I just want the e of t curve, so I'm going to get rid of this times t, and I'm going to switch my limits of integration from 3 to 6. Click solve. I get 0.5 essentially. Let's say 0.495. So about 50% of the fluid spends between 3 and 6 minutes in the reactor. And I can also provide some evidence here of what I've done. I'm going to take another screenshot. And I'm going to just drag this over here to show that's what I've done, how I've obtained it, and say integration performed with Polymath Plus. And that's it. I've answered all of my questions.